In this video, we're going to deal with a very important concept, and that is the discriminants. So, before I tell you exactly what a discriminant is, I would like to draw your attention to a fact. The quadratic equation is x equals to minus b plus minus b square minus 4ac by 2a. Now, what if your b square minus 4ac is equal to minus 2? I told you in an earlier video that you can never have a root of a negative number because a root of a negative number is an imaginary number. It is not real. And in 10th grade, the scope of your syllabus is only for real numbers. So if it doesn't have any real roots, then what happens? So that's where the concept of discriminants comes in. So the discriminant is equal to b square minus 4ac. And what does it tell us? If b square minus 4ac is less than 0, then our equation has no real roots. Like for example, let's say I have a b square minus 4ac equals to minus 3. Let's say this happens. So then you have minus b plus minus under root of negative 3 by 2a. And under root of negative 3 gives an imaginary number. Let's just say that this minus b plus minus root 3 gives you I. It doesn't. Let's just say it gives you an imaginary number. Let's just say it gives you an imaginary number here by 2a. So then you will never get a real solution to this, right? Which is why this b square minus 4ac, if it's ever less than 0, then what we infer from this is our equation quadratic has no real roots. Please note this down. This is very important, and you won't only need this in 10th grade, but also in higher classes as well. Now, I also just want to, with an example, tell you what happens if b square minus 4ac is equal to 0. This is a special case, okay? Okay, let's look at this quadratic x square plus 4. Oh wait, x square plus uh, 12 plus um, 12x plus 36. Let's look at a quadratic equation like this, okay? Now you recognize this as x plus 6 whole square, okay? I'm just going to write that down as well, right? Now, okay, now let's find out the discriminant of this. So you have discriminant equals to b square, which is 144 minus 36 times 4. And you realize that it's 0. So whenever a number has equal roots, like x plus 6 whole square, the roots are minus 6 and minus 6, then your discriminant is equal to 0. So there are three cases you have to know. If your b square minus 4ac is less than 0, it's an imaginary number, it has imaginary roots. Those roots cannot be plotted on a real number line. If your b square minus 4ac is equal to 0, the number has equal roots, like x plus 6 whole square, x plus 3 whole square, or any number that has equal roots. And if the general case, if your b square minus 4ac is greater than 0, then it has real and unequal roots. So there are three simple cases, nothing too difficult to memorize, but this should be, you should never forget this. You should always remember this and never get confused either. Okay, so now let's head into the questions. Find the discriminant of the following equations and hence find the nature of the roots. So let's just solve them for a couple of parts so you get to know exactly what it is. So for the part 1, we know that our d equals to b square minus 4ac. In this case, our b equals to minus 5, right? So it's minus 5 whole square minus 4 times a is 3 and c is minus 2. I'm not writing a, b, c by now because I'm assuming that now you've gone practiced and you're pretty comfortable with this. So that is 25. 4 threes are 12 minus 24. But since it's a negative sign, so it becomes a plus 24, right? And yeah, 25 plus 24, 49. And yeah, I think that's correct. 49, right? So your b square minus 4ac is greater than 0. So it has a real and unequal roots. Okay. Then for part 2, let's just go really fast with this. 2x square minus 3x plus 5 equals to 0. 2x squared minus 3x plus 5 equals to 0. So your b square is 9 minus 4 times 2 times 5, 4ac. This is equal to 9 minus 4, 5, so 22 is 40, minus 31. So if your d is less than 0, you have imaginary roots. Roots, or how it's normally written, no real roots. Okay. So now that we've gotten this out of the way, you can solve the remaining parts on your own. There's nothing too complicated about it. And let's head into some of the more complex questions based on this. So now we need to find the values of k for which each of the following quadratic equations has a real and equal roots. So as we said, what are roots real and equal? Real and equal when d equals to 0. So what do we do? Yeah, so our quadratic equation is 2x square plus kx part 1 plus 3 is equal to 0. Okay. And so what is our d? D equals to b square minus 4ac. In this case, b is k, so it's k square minus 4. A is 2 and c is 3. Okay. And this is equal to k square minus a3 is a 24. Right? So d is equal to k square minus 24. And we just said that d equals to 0. So we can equate this. We can say k square minus 24 is equal to 0. That means that my k square can be equal to 24. So look at this step carefully. K can be equal to plus minus, because k square, k can be negative as well, root 24. Root 24 only gives a positive answer, but k can be both negative and positive. That's why you put the plus minus outside the root sign. And if you want, yeah, okay. Yeah, yeah, if you want, you can simplify this slightly further. It's 4 times 6. You can, this is plus minus 2 root 6. There are two values for k, where two values for k for which your quadratic will have equal roots, 2 root 6 and minus root 2 root 6. If you want, we can check, we can just evaluate this once and check. If we put k as 2 root 6, what happens? So what is our quadratic? Our quadratic is 2x squared plus kx plus 3. 2x squared plus kx plus 3 equals to 0. 2x squared plus kx plus 3 equals 0. Let me just give us some more space. Okay. Yeah. So let's take k as 2 root 6. So we got 2x squared plus 2 root 6 k 2 root 6 x plus 3 equals to 0. And now it may be difficult to see, but yeah, okay, let's just use a quadratic formula here. So we can have x equals to minus 2 root 6 plus minus b square, which is 4 6 are 24, minus 4ac. 4 times 3 is 12 times 2 is 24 by 4. So that is, this becomes 0, so just minus 2 root 6 by 4, which equals to minus root 6 by 2, right? So it just has two roots, minus 6 by root 2, which is exactly what we set out to do. So I think we can do the second part as well. So the second part, the equation is kx times x minus 2 plus 6 equals to 0. Kx times x minus 2 plus 6 equals to 0. Let me just verify for this only. Kx times x minus 2, 6 equals to 0. I think we'll need some more space here. So if we do that. Okay. So let's break this up. Distribute kx. So we have k x squared minus 2kx plus 6 equals to 0. So now again, we have to find the value of k for which this equation has a real and equal roots. So we know the d has to be equal to 0. So b square minus 4ac should be equal to 0, right? So b square is 2k, right? So it should be 2k or minus 2k, in fact, minus 2k whole square minus 4 times a is k times c is 6 is equal to 0. So we have 4k square minus 24k is equal to 0. So you can say 4k square equals to 24k. Divide by 4 on both sides. We get k. I mean, if we divide by 4k, in fact, on both sides, we get k, which equals to 6, right? Yeah, okay, k is equal to 6. Okay, so now again we could plug k equals to 6 into the equation and prove that it has equal roots for this, but I'm pretty sure by now you're confident that this will be true, so I won't get into that right now. Let's move on to the next question. This is a very interesting question, and let's get into it. So if the equation one, I'll just write down the equation once. 1 plus m square times x square. My God, my handwriting. Um, plus 2mcx plus c square minus a square, which is 0. Then we have to prove c square equals to a square times 1 plus m square, right? So, okay. So we have to prove that c square equals to a square times 1 plus m square, and we've been given that this has equal roots. So if it has equal roots, then what do we know? We know that the d equals to 0, and we know that b square minus 4ac equals to 0. What is b square minus 4ac? B square is b is 2mc, right? So it's 2mc whole square minus 4 times a, which is 1 plus m square, times c, which is c square minus a square, b square minus 4ac, and this is equal to 0. Now, if we simplify this, we have 4m square c square minus 4 times, I'm just going to solve this brackets, c square minus a square plus m square c square minus m square a square equals to 0. Now, if we open these brackets further, simplify it further, we get 4m square c square minus 4c square plus 4a square minus 4m square c square plus 4m square a square is equal to 0. So we get this 4m square c square cancelling out. And now we have three terms left. And we have this as um, minus 4c square plus 4a square plus 4m square a square equals to 0. And what did we have to prove? We had to prove that c square equals to a square times 1 plus m square. So we can isolate c square. Okay, by the way, before we do that, we can just divide the entire equation, both sides of the equation by 4, right? Because it's 0, 0 by 4 is 0. So we can write this as minus c square plus a square plus m square a square is equal to 0. Okay, now we just isolate c square, right? So c square, if I take it to the right, if I take it to the RHS, is equal to a square plus m square a square. So c square, if I take out a square out common, 1 plus m square, which is exactly what we had to prove. Okay, now let's move on to the next question. So we have, let me just make this image slightly bigger. For which find the values of p for which each of the following quadratic equations has real roots. Okay, so for the condition for an equation to have real roots is that b square minus 4ac has to be greater than 0. Okay, so now this is last chapter was quadratic inequalities. You just have to form inequalities and solve them. So this is pretty simple. Values of p, right? So let's do part one. Px square plus 4x plus 1 is equal to 0. So b square minus 4ac is equal to b square is 4 minus 4 times p is a times 1, right? And this is equal to 16 minus 4p, right? And we know that 16 minus 4p has to be less than, oh, sorry, greater than greater than 0. Oh, it says it has real roots, and I read it properly. So it can also be equal to 0, right? Because even if the roots are equal, um, they will have, they'll be real. Okay. So now let's just solve this. So if we take 4p to the other side, you have 4p is less than or equal to 16. So p is less than or equal to 4. Okay. Now, just to test this out, let's just plug in one value of this. It's always a good idea whenever you get an answer like this to plug in any one random value and check if it holds. Okay. So let's plug this in. Let's plug in 4 only. So if we say 4x square plus 4x plus 1. So over here, what will be the value of our d? D will be 16 minus 4 fours are 16, right? So it is real because it's greater than or equal to 0. Okay. One really important thing to note here is that although it can be less or equal to 4, p cannot be equal to 0. Why can't it be equal to 0? Because if you look at this equation, px square plus 4x plus 1 equals to 0. If you make your p equals to 0, it's no longer a quadratic equation, right? Because I mentioned this earlier as well. For a quadratic equation, ax squared plus bx plus c equals to 0, a can never be equal to 0. Okay? Because then it becomes a linear equation and whatever we have doesn't hold. That's just one important point I thought that I'd mention. Okay. Now, I think there was a second part to this question. Let's just check what it was. Second part was 4x squared plus 8x minus p equals to 0. 4x squared plus 8x minus p equals to 0. 4x squared plus 8x minus p equals to 0. Okay. So now our discriminant has to be just greater or equal to 0. So we have our discriminant has to be greater than or equal to 0 for it to have real roots. And so b square minus 4ac is equal to 8 square minus 4 times minus p times 4, right? 4ac. And that's 64 minus 4 times minus 4p, which is 64 plus 16p. So 64 plus 16p, 64 plus 16p has to be greater than or equal to 0. And once we have this, we can isolate p and we can say that 16p is greater than or equal to minus 64 and p is greater than or equal to minus 64 over 16, which you should know, p is greater than or equal to minus 4. Okay. If you want, we can test one value of this here as well. If it's greater than or equal to minus 4, let's put in 0 here. So if we put in 0, we have 4x squared plus 8x equals to 0 and 12x squared equals 0. And yes, it does have real roots. So this also works. Okay, now let's move on to the next question. Okay, wait, okay, that's all. Okay, so thank you. Next exercise is 4.5 where we have the quadratic word problems. And don't be daunted by those are also really simple and you should have no worries with them. Thank you.